Good morning everyone, my name is Sophia Thapamagar and today here we are going to discuss about the general conic section. So as you can see the question, the given equation is the equation of parabola and we have to find the tangent at vertex, the axis, length of lattice rectum and the coordinates of vertex and focus. So now we're going to solve it. First of all, we're gonna change the given equation into standard equation form of parabola, which is y square is equals to 4ax. Now for that I'm going to copy the question. This is the given equation of the parabola. Now as you can see that it is in the form, this is in the form of 5x minus 12y whole square, and we're going to write the rest of the term as it is. Now we're gonna add a lambda inside this, which becomes 20 lambda square minus 10 x lambda plus 24y lambda is equals to 0. Now taking x common, we get 2 plus 10 lambda minus, and again taking y common, 24 lambda minus 1 minus lambda square is equals to 0. Now when taking the rest of the term on the right hand side, we get we're gonna give this as a name as equation number 1. Now to find the value of the lambda, we're gonna choose the value of the lambda in such a way that the equation of this and the rest of this equation becomes perpendicularly. So basically this is one of the equation and the rest lambda plus 1 plus lambda square is the second equation. So basically we're gonna find the value of lambda in such a way that this two equation becomes perpendicular. Now for a perpendicular, we know that the slope of equation 2 and equation 3. So now for this we're gonna find the slope. So slope of equation 2 is let me get m1 is equals to minus x, coefficient of x, by minus coefficient of y, which becomes 5 by 12, and again the equation of slope of equation 2 is minus 2 plus 10 lambda by 29 minus 24 lambda. Now for the two line, we get the value of lambda is 1. Now we're going to replace the value of lambda in equation 1 from where which so this is the equation we got after replacing the value of lambda. Now we're going to divide this whole term by root under coefficient root under coefficient of x square plus coefficient of y square, which is 5 square plus 12 whole minus 12 whole square. And to balance it, we're gonna again multiply with 5 square plus minus 12 whole square, and we're going to repeat the same thing on the other side, which is 12x plus 5y plus 2 by root under 12 whole square plus 5 whole square into root under 12 whole square plus 5 whole square. We get 5x minus 12y plus 1 by 13 whole square into 169 is equals to 12x plus 5y plus 2 by 13 into 13, which is x minus 12 plus 1 by 13 whole square is equals to 1 by 13. 12x plus 5y plus 2 by 13, which is by taking 169 on the right hand side. Now, as you can see, this is in the form of y square is equals to 4ax. Now we know lattice rectum equals to 4a. The length of lattice rectum is 4a, so which is 1 by 13. Now in this y square is equals to 4x, y is equals to 0. If you do y is equals to 0, this gives the equation of axis of parabola, whereas x is equals to 0 gives equation of tangent at vertex of parabola. So equation of axis is y is equals to 0, which is 5x minus 12y plus 1 is equals to by 13 is equals to 0, which is 5x minus 12y plus 1 equals to 0, which is our equation number 3, 4, 5. And equation of tangent at vertex is the equation of tangent at vertex is 12x plus 5y plus 2 by 13 equals 0, which is 12x plus 5y plus 2 equals to 0, which is now equation number 6, which gives the equation of tangent at vertex. Now for finding, now we have to find the vertex. So basically we know that if this is a parabola and parabola which is symmetric at x-axis, and if this is the vertex and equation of tangent at vertex, so we can see that the equation of the vertex is the point of intersection of the axis of the parabola and the tangent at vertex. Therefore, by solving equation 5 and 6, we get point of intersection of tangent at vertex and axis of parabola, which is basically the vertex. Now solving this equation, 5x minus 12y plus 1 is equals to 0, and 12x plus 5y plus 2 is equals to 0. In calculator we get x equals to minus 29 by 169, and y is equals to 2 by 169. So this is the point of vertex. So now we're gonna find the focus. So for finding the focus, as you can see that this is a parabola. So focus is basically the point of if this is a focus, then we can see that the focus is a point of intersection of the latus rectum and the axis of parabola. Since we know the equation of axis of parabola, now we're going to find the equation of latus rectum. So equation of latus rectum. The equation of latus rectum is x is equals to a, where x, we know that x is 12x plus 5y plus 2 by 13, and a, we know that 4a is 1 by 13, so a is 1 by 52. So we can write a is 1 by 52, or 12x plus 5y plus 2 is equals to 13 by 52, which is, or 12x plus 5y is equals to 13 by 52 is 13 by 52 minus 2, or we get equation 12x plus 5y plus 7 by 4. Therefore equation of the latus rectum is 48x plus 20y plus 7 is equals to 0. Now which is going to write the equation number 7. Now since this is the point of minus 12y plus 1 is equals to 0, which is the equation of axis. So now solving this, we get solving equation 6 and 5 and 7, we get x comma y, which is minus 2 by 13, and y is 1 by 52, which is the focus. So focus is 2 by 13 and 1 by 52, which is the focus. Now finally we need to find the equation of directrix. So equation of directrix is x is equals to minus a, which is 12x plus 5y plus 2 by 13 is equals to minus by 52, which is 12x plus 5y plus 2 equals to 1 by 4. So this is the required equation of directrix. So we have basically found everything. The equation of directrix, focus, latus rectum length, equation of axis of parabola, tangent at vertex of parabola, and the vertex points. So this is it. Now we are going to solve the second question. For the second question, we are going to first find out whether the given equation is hyperbola or not. So the given equation is 3x squared so now comparing the given equation with the standard form, which is ax squared plus 2hxy plus by square plus 2gx plus 2fy plus c equals to 0. We have here a is equals to 3, b is to minus 3, h is equals to 4, and then we have g is equals to minus 20, f is equals to minus 10, c is equals to 50. Now to find whether it is hyperbola or not, we need to find del, which is minus. Now replacing the value, minus 3 and c is 50 plus 2 into f is minus 10 minus 20, 4 minus 3 into f minus 10 whole square minus 3 into minus 20 whole square minus 50 into 4 whole square, which is minus 450 plus 1600 minus, which gives us 1250, which is not equals to 0, and we need to, since it is not equals to 0, it can be either hyperbola, parabola, or ellipse. So again we need to find h square minus ab, which is 4 whole square minus 3 into minus 3, which gives us 16 plus 9, which is 25, which is greater than 0. Therefore we can write it is the given equation is the equation of hyperbola. So this is the proving only. Now we need to find the center. For center, let del represent the given equation. We can find center by first derivating with respect to x and then again derivating with respect to y. So we take theta by dx, then we get 6x plus 8y minus 40, and if we derivative del theta 5 by dy, then we get 8x minus 6y minus 20. So solving this two equation, we get the value of x and y, which is x is equals to 4 and y is equals to 2, which is the center, which is 4, 2. So in this way we find the center for now. Now for finding, so this is the required equation of the center of the hyperbola. Finding the equation of the hyperbola with respect to its center, let alpha and beta represent the center, which is 4, 2. So the equation of hyperbola with respect to its center is, we have the formula a by h square minus ab by del x square plus 2h by x square plus ab by del xy plus b by h square minus ab by del equals to 1. So first we can find h square minus ab by del, which we have already found. Del is 1250 and h square minus ab is 25, so which is 1 by 50. So we're going to replace the value over here, replace the value of a and this, so we get 3 into 1 by 50 x square plus 2 into 2h is 2 into 4 into 1 by 50 into xy plus minus 3 into 1 by 50 is equals to 1. So we get 3 by 50 x square plus 4 by 25 xy minus 3 by 50 is equals to 1. So this is the, which is in the form of ax square plus 2hxy plus by square is equals to 1. So from here, now I forgot y square over here, so we can see that a is equals to 3 by 50 and b is equals to 4 by 25 and b is equals to 3 by 50 and h is equals to 2 by 25. So over here we basically change the equation with respect to y, which is with respect to center, which is this. Due to it's easier to even solve the further problems when we transform the equation into its standard form. So now for finding length of axis, now we are going to find the length of the transverse axis and the conjugate axis. Now for that we have formula 1 by r to the power 4 pi minus 1 by r to the power square a plus b plus ab minus h square is equals to 0. Now replacing the value of a and b and h, we get minus 1 by square by ab is c by 50 and a is minus 3 by 50. So we get again 3 by 2 into minus 3 by 50 minus h square, which is 2 by 25 whole square equals to 0, or 1 by square minus 1 by, this is 0, so no need to write, and over here we get minus 9 by 2 500 minus 4 by 625 is equals to 0, or 1 by r4 minus 25 by 25 100 equals to 0, or 1 by r4 minus 1 by 100 equals to 0, or 100 minus r4 is equals to 0. Therefore we get r1 whole square is equals to 10 and r2 whole square is equals to minus 10. From the value of r1 and r2 we can also differentiate that it is in hyperbola. For hyperbola, the value of r1 and r2 have different sign, whereas for ellipse they have the same sign, which is both positive. So r1 gives the length of semi-transverse axis, which is root under 10, and r2 gives the length of semi-conjugate axis, which is root under 10. For this, for r2 we will take the real, so we take the magnitude, so that's why it becomes r2 is equals to root 10. We only take real. So we found the length of semi-transverse axis and conjugate axis. Now for finding the equation of axis, we have formula a minus 1 by r1 whole square x plus hy is equals to 0. Now simply replacing the value of a and h and r1, we get 3 by 50 minus 1 by 10 x plus 2 by 25 y is equals to 0, or if we solve them, we get minus 2 by 50x plus 2 by 25 y is equals to 0, which is minus 2x plus 4y is equals to 0, which is, or 2y minus x is equals to 0. So this is 2y minus x is equals to 0. This is the equation of transverse axis with respect to the standard equation, or the equation with taking center as reference. So we have to convert this equation again by taking back from the center of the hyperbola. So we put x is equals to x plus 4 and y, small y is equals to y plus 2, which is capital X is equals to x minus 4 and capital Y is y minus 2. So or and 2 to the power y minus 2 minus x minus 4 is equals to 0, or 2y minus 4 is minus x plus 4 cancels. So we get, therefore the required equation is 2y minus x is equals to 0. 2y minus x is 0, or we can write x minus 2y is equals to 0. Since the value of r1 equals to r2, which is root under 10, so similarly we get the equation of conjugate axis. Equation of conjugate axis is x minus 2y is equals to 10. Otherwise, if the value was not same, then the formula for conjugate axis is a minus 1 by r2 whole square x plus hy is equals to 0, which is similar, only replacing the, instead of r1 it will be r2. So this is the equation of conjugate axis. Now we are going to find the equation of asymptotes of hyperbola. So for hyperbola, it has got asymptotes, so that's why we're going to find. So the formula for that is, we're going to write the same equation of hyperbola, and we're going to add the term del by h square minus ab. So it is 3x square plus 8xy minus 3y square minus 40x minus 20y plus 50, and we're going to add extra term, that is del by h square minus ab equals to 0, which is the required equation. So we have 3x square plus xy minus 3y whole square minus 40x minus 20y plus 50 plus, we know that h square minus ab by del is 1 by 50, so it is 50. Therefore we get 3x squared plus 8xy minus 3y squared minus 40x minus 20y plus 100 is equals to 0, which is the equation of asymptotes of height. So for finding the eccentricity, we have the formula r2 whole square is equals to r2 whole square is equals to r1 whole square into e square minus 1, where r2 square is the length of semi-conjugate axis and r1 is the length of a semi-transverse axis. So by replacing the value, we know r2 is, we take only the real value, so that's why r2 is 10 and r1 is also 10, so e square minus 1, so therefore e square 1 minus 1 is equals to 1, therefore e square is equals to 1 by 2, so e is equals to root 2. Eccentricity is root 2. For now, for finding the length of lattice rectum, we have the formula 2 r2 whole square by r1 whole square, which is 2 into 10 by r2 whole square is 10 and r1 is root 10, which gives us 2 root 10. So this is the length of the lattice rectums. So for finding the focus of hyperbola, we have the formula alpha plus minus er1 cos theta comma beta plus minus er2 sin theta. So alpha and beta, we know it's the center of hyperbola, E is the eccentricity, and r1 and r2 are the axis, transverse axis and conjugate axis. Now theta is basically the angle made by the transverse axis, So for finding, we know every value but we don't know the theta, so for finding theta we take equation of transverse axis, which is x minus 2y is equals to 0. So for finding the theta, we find the slope. We know that slope tan theta is equals to, which is 1 by 2. So we need to find the cos theta and sin theta. So for finding cos theta, we know cos theta is 1 by sec theta, and we know sec theta is root under 1 plus tan square theta. So replacing the value of tan theta, we get 1 plus 1 by 4, which we get 2 by root under 5. So similarly for sin theta, we know sin theta is sin theta, and if we divide by cos theta, then we're going to multiply it to balance. You know sin theta by cos theta is tan theta, and cos theta is 1 by sec theta. So tan theta is 1 by 2 and sec theta is root under 1 plus tan square theta. So we get 1 by 2 into 1 by 2 into and 1 by 1 root under 1 plus tan square theta. We get root under tan square theta, we root under 5 by 4, which is basically we get 1 by root 5. So now we're going to replace the value of sine theta and cos theta over here. Then we get the focus point, which is formula alpha plus minus e r1 cos theta comma beta plus minus e r2 sin theta. So which is alpha is 4 plus minus e is root 2 into r1 is root 10, cos theta is 2 root 5 comma beta is 2 plus minus root 2 root 10, and solving we get 4 plus minus 4 comma 2 plus minus 2, which is the focus. So and now equation of directrix, so which is given by the formula x minus alpha cos theta plus y minus beta sin theta equals to plus minus r1 by e, or x minus 4 2 root 5 plus y minus 2 into 1 by root 5 equals to plus minus r1 is root 10, e is root 2, or 2x minus 8 plus y minus 2 root 5 is equals to plus minus root 5. So or we get 2x plus y minus 10 is equals to plus minus 5, or therefore equation of directrix 2x plus y minus 10 plus minus 5 is equals to 0. So this is the equation of directrix. So in this way we can solve this question. So basically for ellipse it's the same, the formula for the equation of directrix, equation of axis, is a equation of the axis. Even for finding the center, every method and formula is same. So we can solve for the ellipse in similar ways. For hyperbola and ellipse it's the same, whereas for parabola it's a little bit different. So in this way we can solve the general equation of conic section. Application of differential equation in engineering field. Differential equation have a lot of application in engineering field. It has application in mechanics and electrics and other subjects too. Differential equation basically helps us to solve a lot of problems in a easier way. In mechanics we use differential equation in finding velocity, acceleration, force, etc. Similarly in electrical we use differential equation in finding current and all. So we are going to learn about the approach of differential equation in electrical engineering. So as you can see in the question itself, a resistance of 100 ohm and an inductance of 0.5 Henry are connected in series with a battery of 200 volt. Find the current in the circuit. We are given that a resistance and so we can see that it is given that the resistance and inductance are connected in series with a battery of 20 volt and 0.5 Henry. So we know that the total voltage or the total EMF is equals to the voltage across resistance and inductance, which is V plus voltage across resistance and voltage across inductance, which is given by resist I R plus I L di by dt, which is the given. This is the formula. So if we take di by dt, then we get I R by L equals to E by L. So as you can see that this is a differential equation, first order differential equation, which is in the form of linear form. So we can solve it. We can solve this equation by taking integrating factor and all. So by taking all that, we get I equals to E by R 1 minus E to the power minus RT by L, where E is the total EMF, R is the resistance, and R is the resistance, and T is the time, and L is the inductance. So this way we can see that the differential, with the help of differential equation, solving the differential equation, we get the current I in the circuit, which is one of the application of differential equation in electrical engineering. So we can get the value of I by replacing the value of E, which is given as 20, and resistance is 100 ohm. 1 minus e to the power minus 100 into time by inductance is 0.5 Henry, which is 20, which is 2 by 10, which is 5, and 1 minus e to the power minus 200 t, which is, therefore I is equals to 1 by 5, 1 minus e to the power minus 200 t ampere. So as you can see, we have found the current in the circuit as a function of time. So this is the required answer. So we have found the value of I, which is in the function of time as required.